This video, we'll be learning about resistors and resistance. First, let's talk about their definitions. Resistance is the ratio between the potential difference and the current flowing across the conductor. On the other hand, resistor is an electronic component that regulates the current flow of a circuit. And we use the symbol to represent resistors. Let's say we have a conductor of length L and the cross-sectional area is A. Now, the resistance of the specific conductor depends on the length, the area, and also the type of material. Using this, we can derive an equation that is R equals rho L divided by A, where rho is the resistivity. The units of resistivity is ohms per meter, and L is the length of the conductor. The units will be meters, and A is the cross-sectional area. Here, rho is a proportionality constant, and it depends on the material. And the units of resistance is ohms. Let's move on to a question. Here, the resistance of a uniform wire is R. If the wire is stretched, so its length is 3 times the original length, find the new resistance. For this, let's draw a diagram. The length, let's say it is L, and the cross-sectional area is A, and the resistance, we know that it is R. Then, after it is stretched, the length will be 3L, and we don't know the cross-sectional area, and we have to find the new resistance, which is R dash. Since the wire is stretched, the volume remains constant. Therefore, we can say that the volume remains constant. Therefore, A into L is equal to A dash into 3L. Therefore, A dash will be A over 3. Let's apply R equals rho L divided by A to our initial conductor. Then we have rho L over A, which is the first equation. Then let's apply R equals rho L divided by A to the final conductor. Then we will get the length as 3L, and the cross-sectional area is A over 3. Therefore, if we simplify this, we get 9 rho L divided by A. The resistance is R dash. So we can divide the second equation by the first one. Then we will get R dash divided by R is equal to 9. Therefore, R dash will be 9R. Let's move on to the next section, which is resistors in a series. Here, if the resistors are connected in such a way that the same current flows across them, they are connected in series. For an example, let's say this is R1, this is R2, this is R3. the current of I flows through each resistor. Therefore, R1, R2 and R3 are in series. As a result, we can simplify this using a single resistor value. Let's say it is R EQ, and then the current I flows across this resistor. And here, let's say the voltage drop across R1 is V1, across R2 it is V2, and across R3 it is V3. And the voltage drop across REQ will be V, where V is equal to V1 plus V2 plus V3. We also know that V is equal to IR. Therefore, we can write V is equal to IREQ, and V1 is equal to I times R1, and V2 is I times R2, and V3 is I times R3. Since I is common for both the sides, we can just divide it by I. Then we will get the equation REQ is equal to R1 plus R2 plus R3. And this is how we find the equivalent resistance of a series resistor network. Let's try out this question. Here we have to find RAB. Since the same current flows across all these three resistors, 10, 15 and 20 resistors are in series to each other. Therefore, to get the equivalent resistance, we can just add these values, and then we get 45 ohms. Therefore, instead of the three resistors, we can use a single one. So this is how we can simplify this. Now let's say the voltage difference between A and B is 90, and we have to find V1, V2 and V3. For that, let's find I first. Using the simplified circuit, we can find I by using V equals IR equation. V is 90 and I, let's say it is I. R will be 45. Therefore, I is equal to 2 amperes. So we can find V1 by using V1 is equal to R1. V1 will be 2 times R1 is 10 ohms, that is 20 watts. And we can find V2 in the same manner, 2 into 15, which is 30 watts. And V3 will be 2 times 20, which is 40 watts. And the addition of all these three will give us, and the addition will give us 90 watts. Let's move on to another question. Here we have a number of resistors with resistance R, and we have to find the equivalent resistance between A and B. Here, since these are series to each other, we can get their addition. There are n number of resistors, therefore it will be NR. Therefore, using this, let's say we have three 10 ohm resistors, we can find the equivalent resistance ECD. Here the number of resistors will be 3 and the R value will be 10. Therefore it will be 30. Or let's say we have two resistors which are series to each other and a current of I flows across them. The voltage drop across the R1 resistor is V1 and the voltage drop across the R2 resistor is V2. And we can apply V equals R IR to R1 resistor. That will be V1 is equal to IR1, and that is the first equation. And we can also do the same to the second equation to get the second equation from R2. Then V2 is equal to IR2. So if we divide the second equation by the first one, we get V2 divided by V1 is equal to R2 divided by R1. So we can say that when two resistors are connected in series to each other, the ratio between their potential difference is equal to the ratio between their resistances. Example, let's try this out. Now we have two resistors with resistance 10 ohm and 30 ohm. The voltage drop across the 30 ohm resistor is 6 watts, and we have to find the voltage drop across the 10 ohm resistor. For this, we can write the potential difference ratio. V1 divided by 6 will be equal to the resistance ratio, that will be 10 divided by 30. Then if we simplify, we get 2 watts. Now in this case, let's say they have given the total voltage drop across R1 and R2, and we have to find V1 and V2. For this, we can say V is equal to R1 plus R2, and V1 is equal to I times R1, and V2 is equal to I times R2. This is the first equation, this is the second equation, and this is the third equation. So in order to find V1, we can divide 2 by 1. That will give us R1 divided by R1 plus R2. That is V1 is equal to R1 plus R2 times V. Similarly, if we want to find V2, that will be R2 divided by R1 plus R2 times V. Now here, let's try this example. We have to find V1 and V2. To find V1, we can write V1 is equal to 10 times the resistor value R1, that is 3, and the addition of R1 and R2, that is 3 plus 2, that is 5. So we will get the value 6. To find V2, we have R2, that is 2, and the addition 3 plus 2, that is 5, and we have to multiply that by the total voltage drop, that is 10. So 2 divided by 5 times 10, we get 4 watts. Now let's try the second example. We have to find V1, V2 and V3. V1 is equal to the total voltage multiplying by 4 divided by the equivalent resistance, that is 4 plus 5 plus 1, which will give us 10. Therefore V1 will be equal to 12 watts. And we can find V2. V2, we have 30, which is the total voltage, multiplying by 5 divided by the equivalent resistance, that is 10 ohm. That will give us 15 watts. In order to find V3, we can use the equation or the same equation, which is 1 divided by the total equivalent resistance, which is 10, multiplying by the total voltage drop, that is 3 volts. Or we can simplify V3 by subtracting 30 from V1 plus V2, which will be 12 plus 15, and that will be 3 volts. On to the next topic, we have resistors in parallel. So this is the rough sketch of a parallel circuit. We have 3 resistors, R1, R2 and R3, and we have a current I flowing, and it will get separated into I1, I2 and I3. Then we can say that I is equal to I1 plus I2 plus I3. In order for 2 resistors to be parallel, the voltage values at their terminals should be equal. Now in this case, we have A and B as the voltage terminals in all 3 resistors. So if the voltage drop across a resistor here is V, then V is equal to A minus B. So we can write the equation I is equal to I1 plus I2 plus I3, and then I from the equation V equals IR, we can subject I, and then we get I is equal to V over R. And we can simplify this circuit into a single resistor. Let's say the resistance is RT, and the voltage drop across RT is V, and the voltage values at the terminal will be A and B, and the current flowing will be I. Therefore, so from the first equation we can say I is equal to V divided by RT, and I1 will be V divided by R1, and I2 will be V divided by R2, and I3 will be V divided by R3. Since P is common, if we divide this by V, we get 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And this is how we can find the equivalent resistance of a parallel circuit. Now in order to find the equivalent resistance in this, we can find 1 over RT is equal to 1 over 18 plus 1 over 9 plus 1 over 6. And we can get the common factor, which is 18, by multiplying 9 by 2 and 6 by 3. Then we get 1 over RT will be equal to 18 over 6. Then RT will be 3 ohm. And in this example, we have n number of resistors. And in this example, we have n number of resistors of resistance R. All of them are connected in parallel to each other. So we can find the REQ value by this, and we have n terms here. So we get 1 over REQ will be n divided by R. Therefore REQ is equal to R divided by n. Now for an example, let's say we have 6 ohm resistors, and we can easily find their REQ value. which is 6 divided by 3, and the equivalent resistance will be 2. Here let's apply V equals IR to R1. Then we get V is equal to I1 R1. That is the first equation. Now if we apply V equals IR to R2, we will get V equals I2 R2. Since V is the same for each resistor, we can just equate 1 to 2. Then we get I1 R1 will be equal to I2 R2. From this, we can say that I1 divided by I2 is equal to R2 divided by R1. That is, the ratio between the currents is equal to the inverse ratio between the resistance value. And also, if you simplify this, and we have the current I flowing, and the voltage drop is V, and the total equivalent resistance is RT. Then we have the equation V equals I RT. That will be the third equation. And then if we divided 3 by 1, we get IRT is equal to I1 R1. So in order to find I1, we have RT divided by R1 times I. And if we further simplify, RT will be equal to 1 over R1 plus 1 over R2. Then we get 1 over RT is equal to R1 plus R2 divided by R1 times R2. Then RT will be is equal to R2 R1 divided by R1 plus R2. So if we substitute the value here, we get I1 is equal to R2 divided by R1 plus R2 into I divided by R1. This R1 will get cancelled with the other R1. Then we get I1 is equal to R2 divided by R2 plus R1 times I. Using this, let's try out that example. To find I1, we have this equation. So I1 will be equal to R2 is 2 divided by 2 plus 3 times I is 10. Therefore, we get 4 amperes. Similarly, to find I2, we have R1, that is 3 divided by 2 plus 3 times 10, that is 6 amperes. Let's move on to this question. Now here we have to find RAB. Okay, first of all, let's draw a battery so that we don't get confused over the terminals. And then let's simplify the parallel branches, these two. This we can simplify easily by using the Req is equal to R divided by N formula. And then we get 1 ohm. Let's just replace this with a 1 ohm resistor. And the same thing will happen here. So we get 1 ohm and 2 and 1, these two are in series. So instead of them, we can replace them using a single resistor, that is 3, and here also it is 3 ohm. Then we have two 3 ohm resistors in parallel, 3 ohm. Therefore RAB will be 3 ohm divided by 2, that is 1.5 ohm. Now let's move on to the second example. We have to find the equivalent resistance between A and D. So let's draw a battery. As you can see, there's no current flow from this point towards C because it is not a closed loop. Therefore we can remove this, and the same thing happens here. So we can remove these resistors, and then we are left with a circuit like this. And these resistors are series, right? So instead of these two R resistors, we can just add a single resistor of value 2R, and the same can be done here. And then we get 2R here. Now these two resistors are in parallel to each other, so we can find the Req value. That will be R. So let's remove these two. And replace it with the resistor of R value. And then these three resistors are in series. So we get our final answer. RAD will be R plus R plus R, that is 3R.